Hello everybody. Let's have a uh, practical session on PCA. As we already discussed in part 1, PCA, principal component analysis. So we should have at least 100 data sets to perform principal analysis, principal component. It is basically used in factor analysis. So this PCA is used to reduce the dimension of questionnaires. It is a dimension reduction techniques. So if you have a lot of variables or lot of data, right, lot of variables, so what you do, from big you will reduce and make small components. It's called by using PCA. So in our programming to achieve PCA we have very easy procedure. So first of all, let's understand what dataset tells. See, we have PCA data sets, right? We have question number 1, 2, 3, 4. Likewise, we have lot of questionnaires. In that questionnaires, question number 1, you can see statistics make me cry. Means respondent are 1 to 5. So statistics makes me cry. This kind of like a skill questionnaires are given there. And another is, my friends will think I am stupid for not being used to cooperate something. Those are the variables, and those below you can see the data. So here what happened, you have 2571 observation. So 2571 observation means 2571 responded this questionnaire. So you maybe there is 8 variables, right? In that 8 variables, each 1, 2, 3, 4 are the respondent or observation, right? So total is 2571. So already explained, right? 100, there must be a minimum criteria to do PCA is 100 data sets, but we have enough 2571. So let's see what happened. First of all, what I did, I have defined one variable SAQ8, and this is the questionnaires. This is the file name. So when I run it, what happens? See, if I run, it will save data in a SAQ8. So we are not going to call PCA underscore and EFA underscore data. Now onwards we call it as a SAQ8. Let's see what str SAQ8 gives. See, it shows, right, what is label, right, what are the characters, right? Here you can see 1 to 5 strongly agree. Means 1 means strongly agree, 2 means agree, 3 means neither, 4 means disagree, and 5 means might be totally not agree, right? Those things can have, right? So let's check correlation analysis. For to do PCA, we need to have a correlation analysis, right? We need to check in this data set whether it is correlated or not. If the correlation is there, so we have to proceed further. If not correlation means we are not going to do any PCA. That we should understand. See, let's see what correlation gives. See, I see correlation is, this is correlation, right? Now run it. See, all are correlated. Those data are correlated, right? Those are under 1. You can see some are positively correlated and some are negatively correlated. You can see negative correlation, but they are correlation, right? Data in that data sets all have correlation. Look, is there increase more than 1? Is there any data sets? No, right? All are 1 or less than 1, right? So you can say that this data can be taken to further analysis for PCA. So correlation is confirmed. Fine. Step 1. Second, let's see each variable. You can see, I'm just checking Q01, question 1, right? Let's see question 1, how many people have clicked 1, right? I mean to say that questionnaire has a like a scales, right? 1 is strongly agrees, 2 is agree, kind of inputs is there. So now what we do is, now table SAQ8 $Q01 means we are selecting this row, question 1. Table SAQ8 $Q01, what it display how many people, out of 2571 respondent, how many respondent clicked 1, how many respondent click 2, likewise still 5, right? So what I did, proportion, this proportion, PROPORTION is proportion command I have wrapped between this means it will show the percentage. So now let's see we are interested in percentage. So when I run it, see 1 very satisfied, statistics makes me cry, very satisfied 10%, and 2 is 52%, 3 is 28, 4 is 7, and 5 is no good 1, right? 0, 0, 1. You have to divide in 100. So if you add 10, 52, 28, 7, 1, total it should be 100, right? 100%. So I think 1 and 2 is fine for me because it gives more than other value. Now let's go to the first steps. Already checked. Now again perform. Okay. This is starts from correlation. Means we are checking correlation. For checking correlation, we have to mention COR inside of that. We have to mention those data set SAQ8, right? So COR small bracket SAQ8. Let's run it. How what it comes. See, all are correlated. You can see this data is fine. Correlation is there. Data set that go ahead, go and perform further analysis. That's what data sets, right? Now see, I'm just reading. See what happened. Correlation is there. So data set that go ahead, right? What happened in the next? Let me run and see. By using correlation, variance and covariance matrix make. I don't mind. This one is a little bit issues. Let me fix. See, now let's see what it tells. By using correlation, right? Variance and covariance matrix makes. Variance and covariance matrix makes generated eigenvalue, right? So we need to check variance and covariance matrix generated eigenvalue. Means there is a Kaiser rule is there. If the value is 1 or more than 1 plus, then we have to accept it and go for further analysis. Otherwise, we are not going to take those value, those components and all. It will come in the next session, in an upcoming followed by session. Okay. Afterwards, find how much components and factor can take decision is all about PCA. Here, how much components and factor can take decision is all about PCA, right? In linear regression, it will come. We explain R square, right? Here we explain H square in the same way. Okay. Two types of variance in factor analysis. So two types of variance in factor analysis. One is common variance. We take all the items, 8 items, those variables you see, right? These are the 1, 2, 3, 8 items, right? For what? Common variance, 8 items once, and unique variance, divide chunks. For common variance, we are taking all the 8 items, but unique variance, we are dividing chunks, right? Small one. And let's see what other sentence tells. See, in linear regression, R square, coefficient of determinants, that's what we see, right, in linear regression. But in factor analysis, H square, communality, but it is kind of linear R square, okay, in factor analysis. Remember, in linear regression, R square, factor analysis, H square, communality is kind of R square, okay. Old wine in new bottle. There is one famous dialogue, old wine in a new bottle. Old wine means R square only, but new bottle means I am calling H square. That's what it tells. Ultimate both used to see variance only, R square and H square. But here we are using H square. Each item new one, how much influence item 1, item 2, item 3. Okay. Each item new one, how much influence item 1, item 2, item 3. That's what we see from H square, right? Each item new one, how much influence item 1, item 2, item 3. Unique variance 1 minus H, specific and mirror, right? That 1, 2, 3, that is fine. 8 variables. We see item 1 how much to item 2, item 3 till item 8, right? But in unique variance, what we do? 1 minus H square. The specific and error kind of condition we handle, okay? For unique variance, we have two, right? One is common variance. Already explained item 1, item 2, item 3. Likewise, R square we define it, but other one is unique variance, it is kind of 1 minus h square, specific and error kind of explanation is there. So in PCA there is no unique variance, they are all common variance. See, so we are not going to do unique variance and all. In PCA there is no unique variance, there is all common variance, means we are defining item 1, item 2, item 3 like we defined in a simple linear regression R square, right? This much item 1 influence, this much kind of things we do in a PCA. We do not need error terms 1 minus h square something in here, right? But ERV has common plus unique variance, both, which once we complete PCA we go to ERV, right? That has both common and unique variance. Okay, that's why PCA has no statistical test. So PCA has no error. We are not using 1 minus h square, right? Unique variance. So that's why there is no statistical test in PCA. To validate PCA data, we use EFA. One thing you need to remember: if you are validating data, means we are going to use EFA, not PCA. After all generated value, we need to verify or validate, right? For that we use EFA. For that we use EFA. To validate PCA data, we use EFA. That's all. Now let's go what other thing tells. See, in PCA 8 questions we need to normalize if it is in different scales. We do not have a different scale over here, right? We have all like a 5 scale, right? If there is different, we need to normalize. That's what it tells first line. All the questions are measured in the same scale. Okay, our condition is all the questions are measured in the same scale. Let's see. Now we have seen correlation is there. We have data sets and essay keyword. We have saved it in essay keyword variables. We see correlation, right? CUR and essay keyword. We found this data can be data have correlation. That's why we do PC. So for PC we have simple one key word in this R programming. PR comp, right? PR comp in principal component analysis. PR comp and place that variable as a keyword and automatically fit the PCA. If you are calling PR comp and the variable as a keyword and it will automatically fit the PCA. Now if we let's run here. Let's run what it gives. It is saved, right? Now let's see what is PCA. PCA1, right? It gives this kind of values, but we are interested in summary. So let's see summary. See, here we have values for the standard deviation, proportion of variance, cumulative proportion. PCA1 this much, PCA2, PCA3, total 8 components, right? But we are not interested in this standard deviation, proportion of variation, right? Here, see, we got 8 variable standard deviation, we got then proportion of variation also we got, and cumulative percentage also we got. Variance covariance matrix, standard deviation. So we are interested variance covariance matrix, standard deviation means. So we need to add variables, variance. So we need to square. We need variance. So what we do, we square of standard deviation. So we get variance. So here we are interested in variance, right? As earlier I said, simple linear regression R square for variance, and here H square for variance. So here we are interested in variance. For calculating variance, we are going to square root of standard deviation. That's what we do. We need to square the standard to get variance eigenvalue. So PCA1 $DEV, right? This PCA1, PCA1 $DEV, this values comes into PCA1 dot SGB, means we are square root of these things and save into PCA1 dot var. So if you run this, what it comes, let's see. See, now what happened? Just a moment. See, we have just a moment. I don't know something. Screen, just a moment. See, you can see, right? You can see, right? We need square root of standard deviation to get variance. So here you see 3.05, 1.08, something is there, right? So as per the Kaiser rule, right, we have to accept 1 or 1 plus. So you can see we have two components, value is 1. See, PCA1 and PCA2. PCA1 3.05, PCA2 is 1.08. So those two values are accepted, other are not accepted according to the Kaiser rules. So here also I have explained same thing. Those are the output generated. Kaiser criteria, 1 or more than 1 need to remove. Keep 1 or 1 plus, other things you have to remove. So only two principal component has 1 or 1 plus eigenvalue. So we need to retain two only. Okay, we are taking two values, two components only, because those are satisfied Kaiser condition. So we need two components only. So two components may have explanatory power or something integral. Okay, so we are taking two components according to the Kaiser criteria, right? Now other thing is there. So here, right, variance. See here what happened, just a moment. So let's explain. So there are only two eigenvalues, 1 and in 2, so that need to retain 1 and 2 component 1. So based on the theory, first has more variance like 3.05. Our theory tells, right, whenever you perform PCA, your first component will always have a greater value than second component. Likewise, components values are decreases. Same rule satisfied, 3.05, 1.0, 86, 62. Likewise, it decreases. So you have first component. That's what this things tells. Based on the theory, first has more variance like 3.0 and 1. Likewise, other thing with that 8 variables, two dependent variables, PCA1 and PCA2. Within that 8 variables, we are now aware that two dependence variables can be considered in our PCA model. Likewise, we can say, okay, because we do not know aware at beginning, we are not aware, right, which variables are dependent variables. So when we perform PCA, we, according to the Kaiser rule, we have gotten two variables to be considered as a dependent variable. This is PC1 and PC2. PC1 and PC2 might be question R1 and question R2 is enough. Now let's summary what summary tells. Let's run summary also. This summary is, so based on the output, PCA1 has this much, PCA1 has around 40%, it tells, right, 39, see, cumulative percentage, almost 40%, and PCA2 is proportional variance, right? PCA1 has almost 40%, 39.98, PCA2 has 14.18%, that's what it tells. So around this much, 14%, and by adding to 54% around keep and remove other variance capture means one PCA1 considered 39% and 40%, somehow PCA2 somehow 14%. If we add it, we get somehow 55 or 54. That is enough for this. That's what the finalization of this PCA. So let's see some additional things over here. Mandatory table for PCA analysis, we need to take this table, importance of components, and this table we have to take in our research paper, right? We have to take in our research paper. This table is mandatory to show over there because we have to explain this variance. And elbow plot, one of the things, how you can take the value, one is through eigenvalue, another one is through elbow plot. This plot also you can, Kaiser rules is one, another is elbow. Whenever the first bend is there, from that value only you have to take. That's what this elbow plot is. Minimum 100 data must for PCA, 200 minimum for EFA. This already discussed. So first PCA, then only EFA. Okay, first perform PCA, then only EFA. CFA confirmatory factor analysis, you have to. This is additional thing. You should have a 400 minimum data for confirmatory. If we need factor analysis for all, we need 600, right? Out we need to do PCA, EFA and CFA, right? So these packages, let's see what this packages does. SAQViet, you know, right? SAQViet. What did I do over here? For factor analysis we are doing, okay, this is additional things. Kaiser Miller Alkin test, right? The Kaiser Miller Alkin test is used to check whether your data is suitable for factor analysis or not. That's what it is. Why this test is used? The KMO test checks. This is also called KMO test, okay? So for KMO test, what we do? We call site. We install site library, right? We install site library packages, site packages. Then we call site library. Then we perform KMO test inside that data sets. Now, KMO test. The KMO test checks how well variables are related to each other. It tells us whether factor analysis will give reliable result or not. Factor analysis works only when variables share common factors. KMO measures the sampling adequacy of the data. It comprises correlation between variables. See, correlation between variables, partial correlation between variables. If partial correlations are small, factor analysis is appropriate. What can I actually answer? Do my variables have enough common variance to form factors? Do my variables have enough common variance to form factors? Interpretations of KMO result, okay? 0.921, excellent, very suitable. 0.8289, good. 0.7279, accepted. 0.6269, mediocre. So 0.5259 were below 50 not suitable. So as for the theory, so we accept it from this 0.60 and above value. Okay, mediocre value. Alright, poor value or reject. Okay, 0.6 is 0.69 mediocre value. From above you accept it. Okay, exploratory factor analysis, EFA, principal component analysis. When working with questionnaire data, survey list, there are a lot of things over there. So for this, for checking, right? For checking, what we do? Checking data is good for PCA or EFA, right? Checking data is good for PCA or EFA. KMO test. We have written. Now we should run this one. Core test dot Bartlett SAQViet. Now let's run it. See, this is significant. Means this data is good for PCA and CFA. This data is good for PCA and CFA. Okay, so this is significant, and you see, like, data is not good for PCA because it takes 0 means accepting alternative, good for CFA. There is one more thing I would like to show. One more thing I'd like to show. See this value. Do you think below 60? Is there any value below 60? Q1, Q2, Q3, Q4, Q5, Q6, Q7, Q8? No, right? That's why this is accepted. This data is accepted for PCA and EFA analysis. We have 100 only. We have 2,500 something, right? So we can perform PCA and EFA for this, because this KMO test also said above 60, and likewise this significance level also. At last we see that significance, right? Bartlett test. So it said data is okay for data is okay for PCA and EFA. Thank you very much.